Modeling is all about representing a real world system that is difficult to understand using math and science and physics, right? So, that could be a physical model, or in our case, a digital model that's using math. And, the idea is that you can set this up to get an idea of how the real world behaves as accurate as we can. And in terms of flood prevention, hydrologic modeling is all about getting an answer on how much water needing to be drained, right? How much water is being created by this rain event. And, in terms of flood prevention, it's usually a first step in identifying what is your problem, where's your areas that are at risk, and where can we focus on actually preventing the flooding, right? Before you can do any type of flood prevention, you need to understand where the flooding occurs. Over time, the software, especially in recent years, has gotten a lot more complicated. Originally the models weren't geo-referenced or anything. It was, stick and line models, just very, very simple. And in recent years, it's gotten very, very advanced. There's all sorts of inputs, especially on these large scale LWI models. We input things like gridded rainfall, bathymetry data, and terrain data, all kinds of gauge data. And we use like real life stations to actually calibrate and make sure the model is accurate. I think that's really an area of focus where the quality you get out is the quality you put in. So, a lot of time is spent to make sure that what you're actually putting into the model is ready and accurate.